Alright, before we get started, what I want to do right now, let's see if this works, great note. Okay, good, it works. What I want to do right now is just practice a little bit of the last chapter, the chapter 5.3, just to give ourselves a refresher, because it's been a week at least since we've done anything. So let's look at some of the questions on homework. So let's say just number 19, start as a good example. We have the integral, and that's a terrible integral symbol. Let me do that again. So the integral from -1 to 2 of x cubed minus 2x dx. Okay? Now, this is kind of written out several different ways. I've seen, like when I did it when I was in college was a little bit different than the way I do it now. Because basically I basically just find capital F of x, which we know to be the antiderivative, and then I do capital F of 2 minus capital F of, and that's capital F of -1. Okay, and that's what I do now, which is perfectly fine. But just to show you an idea of what I did in college and how it's written out, like some people you may see afterwards how they write it out. You're still going to find the antiderivative, but instead you're going to write it, just basically write down the antiderivative. So we're going to, let's do this in different colors so we see the change. We're going to add 1 and then divide by 4. We're going to add 1 to 1 and divide by 2. And we don't worry about a constant because this is a definite integral, which means there are values here. If there are no values here, we'll look at what that does later on. So let me do I have it somewhere? There you are. Alright, so, sorry, I'm just having trouble with putting my hand on the screen. Alright, so we're still going to find the antiderivative, which is basically 1/4 x to the 4th minus x squared, okay? But you're going to see this right here, with like a parentheses and then a solid bar, okay? And that bar is going to have the values -1 to 2 on it, okay? I don't know why they do it this way. It's in our book somewhere. But to be honest, I prefer the other way. It's just find capital F of x and do, f of 2 minus f of b. Just basically use the fundamental theorem of calculus. But you may see it written this way. And it's the same thing. It just means we're going to do the top number first. So I plug in 1/4 of 2 to the 4th minus 2 squared. So it's going to be 1/4 of 16 minus 4, which is 4 minus 4, which is 0. All right. So I have 0 minus, plugging -1, that's going to give you 1/4 of -1 to the 4th minus -1 squared, which is going to give you 1/4 minus 1, which is -3/4. So minus a -3/4 becomes positive 3/4. And that's the answer. Okay, so again, just a refresher, let's look at one a little bit more challenging. Let's move on down to 29 and 31, just so we remember that we're going to do some trig, and yes, you got to know your trig, and I got to remember some of this because I got to remember the antiderivative of secant squared. I want to say is tangent. I want to say the derivative tangent is secant squared. I may even have to check myself, so yeah, we don't always remember it. Alright, let's get rid of this. Alright, so let's look at number 29. Now, number 29, we have the integral from 1 to 9 of x minus 1 over square root of x dx. Now, here we can't do this, not with what we know, because there's no way for you to be able to do this. So what you're going to do is simplify this first, okay? So simplifying this first, we are going to do the integral from 1 to 9 of x to the 1 minus 1 over x to the 1/2, and we're actually going to divide each by x to the 1/2. So this is going to become integral from 1 to 9 of x to the 1/2, because when you divide you subtract exponents, and this becomes minus x to the negative 1/2 dx. So now that it's simplified, and yes, I use that word loosely, simplified, should be 9 here. So now we're going to take the antiderivative. So we're going to add 1, and then instead of dividing by 3/2, I'm going to multiply by the reciprocal, 2/3. Okay, so add 1, that's going to give me 1/2, so multiply by the reciprocal gives me 2. Okay, so that's going to give you 2/3 x to the 3/2 minus 2x to the 1/2. Okay, again, this is all right. So this is capital F of x. I'm just going to continue to do this. So f of 9 minus f of 1. Now f of 9, that's going to be fun. Well, let's do that. F of 9. This 2/3 9 to the 3/2 minus 2 times 9 to the 1/2. Now, this means I'm going to square root 9, which gives me 3, and then raise it to the 3rd power, which is 27. And 2/3 of 27 is 18. All right, so again, square root of 9 is 2, so minus 6, that gives you 12. So f of 9 is 12. All right, then we have to do f of 1, which is 2/3 times 1 to the 3/2 power, which is just 1, minus 2 times 1, square root of 1, basically. So it comes 2/3 minus 2, which is negative 4/3 or negative 1 1/3. So it becomes 12 minus a negative 4/3, which I'm just going to write as 13 and 1/3. But if you want to write it as 40/3, that's fine too. Don't know what just happened there. Okay. All right. So we'll do one trig function. So let's see here. All right, so so the only trig question I see here is number 31, which is the integral from 0 to pi over 4 of secant squared t dt. All right, and I'm pretty certain, let me look it up real quick, or the integral secant squared. So what's that? Yep. So since the derivative of tangent squared is secant squared x, that means the antiderivative of secant squared x is tangent. So this just becomes tangent x, or tangent t, really. That's f of t. So we need to do f of pi over 4 minus f of 0. Now, again, f of 0 for tangent is 0. All right, f of pi over 4 is 1. So that gives you 1. See, that wasn't too bad. Just got to know your unit circle. So, yeah, I know, I said it. All right. So let's close that. Well, let's clear everything first. Okay, well, I minimized it. Okay. So we're going to move on to the next section, which is indefinite integrals and net change theorem. Okay, so not too bad. Really, it's not that big a deal at all. Okay, So here's some properties. Here, let me just really quickly go through this. Indefinite integrals means just antiderivative. That's it. It means right here. So indefinite integrals means antiderivative. If indefinite integrals means there's no numbers here. So, for example, let me make this a little bigger. Last question was integral, and I said, integral of 0 to pi over 4 of secant squared x dx. It was t, but I don't care. This is a definite integral. Because there's numbers here. If it was just integral of secant squared x dx, this would be an indefinite integral, which just means antiderivative. So you really already know this, because the one thing we didn't do on definite integrals is add the constant. So that would be tangent x plus c, done. Okay. So I'll move that over there. So here we have the indefinite integral of x squared. So again, we add 1, divide by 3, and just add the c. Done. So here we have definite integral, we have bounds, okay, indefinite integral, and then there's our function right there. That's nifty. All right, so here's some properties of indefinite integrals. It even gives you the trig function, so you may want to jot this down in your notes so you remember your trig functions, because you're not going to be given this. So you got to know your trig functions. Even though I looked it up, you got to know it because you're the student, I'm the teacher. Ha ha ha. All right. Indefinite integral of a constant. You can factor out any constant. Okay, it's not a big deal if you do or don't. It really makes no difference. But if there's a common constant you can factor out, just factor it out. The definite integral of a constant is a constant x plus c. I mean, you basically know the rules of integration. Okay, because you know the rules of antiderivatives. It's the same rules. Okay. One thing you have to be careful for is anytime you have a asymptote. Okay, so when they say find the integral of this technically would be your answer. Let me zoom in again. So this technically would be your answer, but not quite, okay, because you have an asymptote here, which means you have two separate functions where you have to kind of make sure you state that x cannot equal 0. So anytime you have an asymptote, which means you have x left in the denominator, I'm going to say you're not going to have a lot of these, okay, so don't stress this too much. But you have to basically separate as a piecewise function with two separate constants for reasons, okay? Just to be, you know the word, you know the word, and I know the word. I wouldn't say nitpicky, but, you know, I can't think of it. I'm glad you know the word. Okay. So here we can find the general indefinite integral. We can do this separate. You don't have to do these together. So you just do the integral of 10x to the fourth and the integral of secant squared x, because you can bring the 2 outside. So again, the 10 we can leave outside, the 2 we can leave outside. Integral of this is x to the 5th over 5, and then we multiply by 10 to get 2x to the 5th over 5. Integral of this is tangent, so 2 tangent, and then just add the constant. So give me a second, I'm getting emails and the like. So I'm just treating this as class, and I'm just looking at my phone. Yeah, right. All right. Okay. Nothing big deal. All right, here, again, evaluate the indefinite integral of this. You would want to simplify this, because we don't have a way to do this. We would do this, we'd have a way to do this in the next section, the very last section of Chapter 5, which is the substitution method. So right now we have to simplify as much as possible. So here, simplify means 1 over sine, and then cosine over sine, which we know to be tangent. So 1 over sine is cosecant. Cosine over sine is cotangent, and the integral of cosecant cotangent, if you remember, because it was just here a second ago, right here. Oh, you can see my little tiny pen dot I have here, that is negative cosecant x plus c. And that's what we get. All right, so not a big deal. I mean, this is really it. Nothing to stress. The idea is if we have bounds, we actually run it through. We don't have to worry about a constant. If we don't have bounds, then we're done. Then we just add the constant, and that's it. So let's look. Is there anything else? I don't think there is. So okay, let's look at this. When dealing with okay, that right there. The difference between displacement and distance. Okay, displacement we would treat just as a regular integral. We don't do anything special with it. It's just overall change in position. Okay, so really we don't do anything special. But overall distance traveled is the absolute value of the function. Okay, which means anytime it's below the x-axis. So let me do this. Let me just screen write this. All right. So anytime, all right, so here, displacement is just what's the change in position. So from here to here, how much did it change? Done. Okay. Now with distance, we want to know how far did it travel during this time. Okay. Now that's going to be different. Okay. So that's absolute value. We want all of these to be positive so we can add them all together. Okay. So to do that, we have to know where it crosses the x-axis. So we need to set the function equal to 0 and solve. So let me discard this. Let's look at the function. Here's the function. So, okay, screen right again. So this is the function. Displacement would just be the integral. We want to know from 1 to 4. So 1 to 4 of t squared minus t minus 6 dt, which just means antiderivative, so 1/3 t cubed plus 1/2 t squared minus 6t, and then we plug in 4 and then plug in 1. 4 would give us 1/3 of 64, so 64 over 3, plus 8 minus 24. Now 64 over 3 is 21 and 1/3. Yeah. Plus 8 minus 24, so that'd be 29 and 1/3 minus 24, so that's 5 and 1/3. Now if I plug in 1, okay, plug in 1, that's going to give me 1/3 plus 1/2 minus 6. So it's going to become 1/3 plus 1/2, that is 5/6 minus 6, that becomes 5 and 1/6. So that becomes negative 5, so minus a negative 5 and 1/6. So make sure I'm doing it. So that becomes positive, and I get 10 and what's the word? 10 and 1/3 plus 1/6, 10 and a half. Right. So let's do it right. So it gives you 10 and 1/2. Now you have your book here. Something went wrong. Oh, it's a minus. That's a minus, not a plus. I wrote plus, no wonder. Okay, and I can't bring it back here. Awesome. That's why I should have my note out. I should really keep my notes up. So if I remember, screen right again. So f of t was 1/3 t cubed minus 1/2 t squared minus 6t, and it's minus, not plus, so if I plug in 4, I get 64 over 3. That still changes. That's the same. But instead of plus 8, it's minus 8 minus 24. So I end up with 21 1/3 minus 32. And that is 10 2/3. Negative 10 2/3. Yep. And then I plug in 1. That's going to give me 1/3 minus 1/2 minus 6. So that becomes, see here, negative 6 1/6. I think so. So when I subtracting negative 6 1/6 from that, that's going to become positive, which is going to give me a negative 4 1/2, which I think is the correct answer. Yeah, negative 4 1/2. Now, to find the overall distance traveled, we need to find where the function crossed the x-axis. Basically, we kind of need to give a little tiny bit graph of the function. Okay, so if we factor that, that gives you t minus 3, t plus 2, which means the graph crosses the x-axis at negative 2. Okay, 1, 2, 3, and 3. Now, I'm only worried about this interval, so from 1 to 4. So it's going to look something like that. Little curve there, sorry. I don't know how far, though. But it seems the majority of it is still going to be under the x-axis. That's why it ended up being negative. The overall change is negative because it's under the x-axis majority. So what we're going to do is we're going to do two separate two separate sets of integration. One, we're going to do the integral of, negative the integral of the negative part. And then we do the negative of a negative becomes positive. So we're going to do negative integral of 1 to 3, where the function is negative, of t squared minus t minus 6. And we're going to do plus the integral from 3 to 4 of t squared minus t plus minus 6. Again, dt. So let's look at let's just create a note, make it easier. All right, so it is negative integral from 1 to 3 of t squared minus t minus 6 dt plus positive integral from 3 to 4 of t squared minus t minus 6 dt. So there's still, the nice thing is the antiderivative is still the same. F of t, and that's a capital F. Okay, f of t is 1/3 t cubed minus 1/2 t squared minus 6t. All right, we already know f of 1 because we plugged that in earlier. F of 1, the smaller value, is a number. I think no, I don't have it anymore. I erased it. I want to say when we did it, we got negative 6 1/6. So negative 6 1/6. F of 3 we don't have, so we'll plug that in. That's going to give me 1/3 27, so 9. minus 1/2 of 9, so 4.5, minus 18. So that's going to be negative 13 and 1/2. All right. And then we have f of 4, which I think we already know. We wrote that as 10 and 1/3, negative 10 and 1/3. Okay. So, what we're going to do here, scroll down just a little bit, is this first integral is negative of f of 3 minus f of 1. So negative, parentheses, f of 3 minus f of 1. Plus, and that's not what I want. The second integral was f of 3 to f of 4, so f of 4 minus f of 3. So plugging all the numbers in, negative 13 and 1/2 minus a negative 6 and 1/6 plus negative 10 and 1/3 minus a negative 13 and 1/2. So that's going to become positive, that's going to become positive. We get, so negative, it really becomes, if I distribute, I'm just going to distribute the negative through because I'm going to make things easier. So it's going to become 13 and 1/2 minus 6 and 1/6. So 13 minus 6 is 7. 1/2 minus 1/6 is 1/3. All right. Negative 10 and 1/3 plus 13 and a half, so it becomes 13 minus 10, which is 3. And 1/3 minus 1/2. Oh no, 1/2 minus 1/3 is 1/6. So 1/6. So, or we could write it as 22 over 3 plus 19 over 6, which would be, if I multiply by 2, 44 over 6 plus 19 over 6, which is 63 over 6, or 1 divided by 3, 21 over 2. Nope, something happened here. What am I off by? Off by 2 somehow. I say I'm off by 2. I'm off by 2/3. Or 1/3. I'm off by 1/3. Alright. Let me plug this in the calculator so I'm doing this in my head. So give me a second. So we got So -6 and 1/6, we're good there. -13.5, I'm good there. That's where I'm wrong. It should be 2/3. That's where it is, 2/3. Okay. Why should be 2/3? Plug in 4. Okay. Never mind. Okay. So that's 2/3. That's where I'm off. So that becomes 2 and 5/6. Which ends up being 17/6, which gives you 61/6, which is your answer. Okay, glad we cleared that up. So again, if they're asking for, minimize this, if they're asking for overall displacement, just regular old antiderivative, plug in your values, you're done. But if they're asking for distance traveled, everything must be, that's the absolute value of the function. Okay, so the absolute value of the function. All right, so you have to do all positive areas. It does help to graph it. Even doesn't have to be a perfect graph, but a general idea of the graph. Okay. All right, that pretty much covers everything. So let's see what I'm going to give you for homework. Ha ha ha. Let's see here. Let's just write this down. Let me post this, say this, and post it at the same time. So here we go. Nope, not what I want to do. What are you still posting for? Ridiculous. Edit. Post. Post. What's wrong with you? Alright, maybe I don't need to do that. Let me just do this. Fresh, give me a second. That's better. Okay, alright. Okay. Dang, that's been working on that all day. Alright, sorry, you can't see what's going on because you're at home watching this video and I'm here at 9:30 at night trying to get everything done. Let's see here. Grades, classwork, create assignment 5 point. I should put 5 point, chapter 5 quiz because I gotta do that too. So chapter 5 quiz. I really should grade things at some point, but who knows when I'm gonna have time to do that. It's 5 questions. We'll say they're 5 points apiece, so 25. Category quizzes. All students, no due date. It was before we left, so we'll say the 12th. Cancel. Topic, chapter 5. Assign. Okay. And then assignment 5.4. This is page, whatever page. We'll start this on 329. Now you all should have your book at home, but in case you don't, I think I did post an actual PDF file of the book, so either way it's fine. Alright, so 100 or 5 points, homework, due date, we'll say Friday. No topic, chapter 5. Now questions, the questions will be, alright, we'll start with 7. Go ahead and do 9 too, so 7, 9, and 11. And got to do at least one trig question. So let's say 13. All right. So there's not really a big point in giving you a ton of these because these are the same of the other homework. So evaluate the integral. So you actually have answers to these. I mean, you've actually done these. This was basically 5.3 again, where you're just doing the definite integral. So it's just use the fundamental theorem of calculus. You're fine. But I'll give you a few of these to do just to refresh yourself. We'll do an easy one like number 19. And then we'll do one a little bit more interesting, number 25. Now, I'm going to always give you the red letter questions because those are fun. And you know what I mean by fun. I'm going to give you a couple trig questions. Let's do 33 and 35. And let's see here. Let's do one that shows displacement and stuff like that. So, don't see any here. Don't see any here. Go ahead and do 45. Just because I want you to be able to think about that one. Okay. Alright, so let's look at some displacement. Alright, so 55 and 57, and that'll be it. 57. Okay. Alright, assign. Now I'm going to assign this, but I'm also going to post a video, so give me a second. So, alright. I say give me a second, like you're listening to this right now. So yeah, tomorrow, or tonight when you see this, I will be posting a video with this as well. So I'm going to post it, and then later, I say a few minutes later, post the video, because it has to upload to YouTube. So if you have any questions about uploading things to YouTube, watching things on YouTube, you should be able to find a way to get onto YouTube. There is a way to use the school computers if you actually went and got a Chromebook this week. I don't know how that is, but I've been told there's a way to do it, because I was told how to do it, and then I forgot, because I don't have to worry about it. But for you guys, I will try to see if I can find. If anybody says they can't watch the video on YouTube, at least, again, you have a way. You know you have a way to watch YouTube videos. So, anywho, let me stop this. And I'll do the last lesson sometime, probably Friday. And then we're just going to go. You'll see lessons pop up. Just do lessons as they come up. I would say I'm going to keep up with the day-to-day stuff, but that's not going to be true. So we got to at least get through Chapter 5 and Chapter 6. Okay, and that's really the big things. Chapter 5 and Chapter 6. We only have one more lesson in Chapter 5, and there's only 5 lessons in Chapter 6. There are some things in Chapter 7 I want to do, and we're going to do, because you need to know it if you're going to go on to Cal 2. You need to know how to do derivatives of logarithmic functions and integration of logarithmic functions, derivatives of exponential functions and integration of exponential functions, as long as e, and you need to know L'Hopital's rule. So those are things I want to cover in Chapter 7. It's really going to be brief, but that'll just kind of be the end of it. I don't know what's going to happen. I don't know how I'm going to test you guys. I'm going to figure that out. There's some ways I found I can do this online, but everything's going to be open notes, no matter what, because how would I know? So I'm just expecting it to be open notes. So yeah, we'll get this done. So y'all have a good day.